For the second video, of course, we will be showing you the solution to problem number 2. And problem number 2 is basically similar to problem number 1. Only this time, what if we are to consider the forward biased resistance of each of the diodes, which is basically equal to 50. So we go back to the diagram. So it's the same diagram. I I did not delete this portion anymore because I'll explain this by and by. So firstly, let's go back to the discussion on how full wave rectification is implemented using this setup. So again, for our input, we have two alternations. So since this is an alternating current, it has a positive and a negative alternation. Let me color the positive to be purple and the negative to be green. So if we're going to trace from the positive alternation, purple, there. So we start at the positive terminal and it will approach this node and it will choose to pass through any of these two branches. However, looking at the first branch, it's going to have this diode in a reverse biased condition. So which means this diode is now offering a very high resistance. So it will not choose to pass through that branch. It will rather pass through this one. And then again, we'll approach this node and then we'll choose to pass through two branches again. So for the first branch, it will not choose to pass through this diode because again, it's going to have this reversed bias. So you have a very high resistance here. So it will rather pass through this branch and will divide into two. And hence, current will enter at this terminal and will cause here a positive deflection. And then we'll go back to negative. Now, during the negative cycle or negative alternation, negative half cycle, we use green this time. So let me just check also, or let me emphasize that from the positive half cycle, it forward biased this. Oh, I'm sorry, I have to continue so that you could see. So it will enter here, two branches, go back to this node, will combine to a single branch, passing through this node, and of course it will not pass through this branch anymore. That's the positive terminal. So it's going to approach the negative terminal. So it will pass through this, no problem. This is forward biased back to negative. So it passed through two diodes. If we name the diodes, say this is diode 1, say this is diode 2, diode 3, and say this is diode 4. For the positive alternation, current passed through diodes 2 and 3. So you have a resistance Rs in series with the forward biased resistance of D2, in series with the parallel combination of 500 to 500, going back in series to the forward biased resistance of D3, going negative. So for the positive half cycle, we could probably redraw if necessary. Yes, I would choose to redraw so that you can see. So this is Rs. So it passed through the forward bias resistance of diode 2. So series. And then series to the parallel combination of 500, 500. There. And then this is now the forward biased resistance of diode 3. This time for the negative half cycle, so we said I'm going to use green for the next half cycle. So starting at the negative terminal this time, so it will pass through here, will approach this node. Again, it will not choose to pass through this branch because this one is reversed bias this time. Rather, it will choose to pass this branch. So this one is forward biased for the negative half cycle. And for the negative half cycle, again, it will not choose, it will approach this node and will not choose to pass through this diode because this is reversed. So it will pass through this branch again, will divide into two, and current will pass through here, and similarly will pass through here also. So from this node here and this one. So which means to say it's entering the same terminal of the meter movement. It did not enter the other terminal, because if it entered the other terminal, the waveform should be again alternating. But no, it entered the same terminal. So it will deflect similarly at how it deflected from the positive half cycle. So hence, if you're going to continue positive, negative, this is going to be the response in your meter movement. Hence, you have full wave rectification. Okay? And then back will combine to this node, and then we'll go back. This time it has to approach the positive terminal. So go back here. It will not pass through D3 anymore, because if it did, it's just going back to the same terminal. Has to go back to positive terminal. So it will pass through this branch this time and forward bias the D1. Then approach this node and then back to before the positive terminal, it has RS. Okay? And then back to the positive terminal. So if for the positive alternation, it started at the positive terminal going negative terminal. For the negative alternation this time, it starts at the negative terminal. So we'll approach a resistance, forward bias resistance of D4. And then in series with the parallel combination of the two 500s again, and then going to D1. So please pay attention to the color code. And then going RS, going to the positive terminal. There. So this implies two things. Number one is that whatever the alternation is, may it be positive or negative, take note that technically you have the same circuit. You have an RS in series with a forward biased resistance, in series with the two 500s in parallel, in series with another forward biased resistance, both for the positive and for the negative alternation. So, meaning it's the same, because obviously you're going to make use of identical diodes for your bridge. Doesn't make sense for you to make use of different diodes. So which means to say the forward biased resistances of D1, D2, D3, D4 must be approximately equal. So this circuit, this one, is the same as this circuit. So hence the total resistance will be RS in series with RD in series with 500 500 in series with another RD. Secondly, the total current for each of the alternation is also the same. So the bridge will not affect the resistance of the bridge will not affect the total current because they are connected in series as seen from these two terminals of the probe. So hence in our solution, we will not repeat anymore the total current 2mA and the sensitivity DC of 2M. In fact, I shouldn't have erased also the SAC because it's technically equal. So we have solved this one already. So zero point 0.9 of 1 over 2 milli, which is 4,500 there. So what has changed? It's the total resistance. So again, SAC multiplied to the VAC range should give us the total resistance. And this will now be 4,500 times 10 is equal to RS in series with, again, we have two forward biased resistances here, so I'll just multiply this by 2, each of which has a value of 50. Then in series also with the parallel combination, 500 500 is 250 there. So our RS this time is 4,500 minus 250 is 4,250 minus 100 is 4,150 ohms. There you have it.